Let us discuss one confusion arises to the students by taking one example. One measurement is given 4.700 meters. Suppose if I write in centimeters, so 1 meter equal to 100 centimeters, so 100 into this one. So what do you get? 470.0 centimeter, and 1 centimeter equal to 10 millimeters again. So 4700 millimeter. Suppose if I go for kilometers means 1 meter equal to 10 to the power of minus 3. So 0.004700 kilometers. Now if you think of number of significant figures, here you can observe one thing. Here you are having decimal point, so these are significant. So how many significant figures? 1, 2, 3, 4. This one has 4 significant figures. Now these zeros again significant because you are having decimal point, so you are having 4 significant figures. Here it does not have any decimal point. That's why these zeros are insignificant. Only 4, 7 are significant. So it has 2 significant figures. Next here, these zeros are insignificant and these zeros are significant. So 4700. These 4 are significant, this is not. So it has 4 significant figures. So here what happens is, number of significant figures are changing. If you change the unit, number of significant figures changing, but actually it should not happen. So for not changing number of significant figures, instead of writing this, we prefer scientific notation. So what scientific notation tells you? 4.700 meters. So it has 4 significant figures. Suppose if you want to convert to centimeters, so you do like this: 4.700, 1 meter is 10 to the power of 2 centimeters. Better you take the help of 10 square, 10 cube and so on. So here also 4.700 into 10 to the power of 3 millimeters, or 4.700 into 10 to the power of minus 3 kilometers. So here what will happen? Number of significant figures of this measurement does not change, and we even don't think of this power. So it is just for conversion, and while counting the number of significant figures, we don't talk about this power, 10 to the power of something, we don't consider, only we will say this. So this type of problem may arise, that you can overcome by this scientific notation. And while solving problems, say while comparing the gravitational force with the electrostatic force is how many. Sometimes in physics you are asked the electrostatic force is how many times to the gravitational force. In that case, exact value we don't answer, but to the 10 to the power of something, some order we are going to answer. So how we are going to talk about the order of this power? See, 4.32 into 10 to the power of 5 something you are having. This number is less than or equal to 5. So if the number is less than or equal to 5, just keep 5 only, don't change. So its order is 10 to the power of 5 only. Suppose if it is greater than 5, that means 5 point something or 6.84 into 10 to the power of some minus 10. It is greater than 5. That's why you increase this power by 1. That means 10 to the power of minus 10 plus 1. So the order is 10 to the power of minus 9. Or 7.831 into 10 to the power of some 10. So it is greater than 5. That's why you increase this power by 1. So to the what order? 10 to the power of 11 order. So while talking about the order, we will see whether the multiplied number is less than or equal to 5, then you keep this power unstepped. If greater than 5, then you increase this power by 1 and then you give that value is the answer or order.